So welcome. You can see I've gone a bit further. I'm going to take you back to show you what I did and give you another head start on this. So the initial dimension we had, by the time I put the hinge, it was a bit shooting out, so I had to make adjustment on the main body, on the flange of the main body, and make it coming further. I'm going to measure from the end of the flange to this is about 1.5 mm, 1.25 mm to make room for the my hinge, choice of hinge. And another thing we also do most times is sometimes not to see if the things clash. So to avoid clashing, we might need to make those tolerances, and that's what we did. And there was no interference between the main body and the hinge and every other thing, so this worked perfectly. So I'm going to show you how what changes are done. So let me just do save as for this assembly and delete what I've done, then save as row 2. Alright, so this is it. Save as, we had that, we had these. Gonna do a copy. Okay, so let me just do this. Let's do this. So gonna do a copy of everything. Okay, Control C. No, I just want to let me know what about that copy. So I've done the save as. Always not save this and come back. So what I did was when I want to open the main body, you're gonna see. I mean, whatever you've done so far with the previous videos are fine. So the changes we've done to the main body, since we need to extend this further, I'd gone to make those changes there. So this is what I did. I have a flange that needs to move further, so it means I need to change the flange depth of this by 3.25. was 30. Yeah, 3.25 because that was the clearance I had on the edge of the enclosure. So if you look at this part in your drawing, go to this main body, put 3.25. That's because I want the edge of the hinge isolated to flush with the edge of the enclosure. So in your own, you go to 3.25, change the add the 30 plus 3.25, and if you come over here, done some things on this part. So on this part, increase by 3.25. Then on this part, so I'm gonna just go out. So on this part of the draw of the flange, this one here, the second one is 1, 2, 3. So the second flange or the top, having moved in by 3.25, it means that this are moving by 3.25 to the right and to the left. I remember both sides to the right, my right, and this is moving in by 3.25. So meaning that the offset we've created here, we need to, it was 30 before. So what I did was, if you over it, it's immediately set 37, which is equivalent to the length of the flange. If you look at it, you're going to give us 33.25, which is 30 plus 3.25. So you can either write 30 plus 3.25 as it was before, or you link it to it so that whenever there is any changes on this edge, it automatically do the offset by itself and respect the tolerance we give it. So I connected with the parameter. So what I did was just go back to that to the flange and get the parameter there. You over you're gonna see D37. So that was the same parameter I picked. I just picked the parameter name and plug it into this flange. So another constraint you might want to try and avoid when you design these things is all of these things you might want to find out if your manufacturers can achieve them. I increased the the distance from the edge before was about, I'm not quite sure, but I'm gonna find out now. So what I added was width minus 20, which is 450, which is like the width is, let's check the parameter because I can't remember what the width is. So I need to stop this. I need to pull out the parameter. I mean, this my stuff is covering it. I could move it to check the FFX. So I could go to manage the parameter. So the width is my user parameter. Width is 450. So 450 minus 20, that's 430. So the width we had was 430. Clearance of about 430. That was clearance of about 10 on both ends, which is 450 minus 20. That's 10 on both ends. And now rather than 10, what we did was to make room for this edge. I need to also give a tolerance between the end of the door and the interior flange face of the interior flange face of the door and the flange on the enclosure. So what I did was I had to do some calculation. So that's it was I need to subtract 8, that's 4 on both sides, minus another 3.25 on both sides to accommodate the inch that I put there. So this is just specifying the inch, so which is what I've done. So if I slice it, just like I told you, I'm gonna slice it. Go to view, slice, half section on the right side, just to see. If you see this wall I'm talking about, this face and the internal face of the door. Sometimes you need to be conscious. If you want to use rubber, you keep tolerance. If you don't want to, in most cases you might not need rubber if the clearance is okay. You see the distance between the interior faces is 5 mm from the top, so I could bring it further in case if I won't need. Because why we did this opening here is water ingress. If it rains, the water can just flow through all this gutter and it drains off. So it's like a form of drain for water to not get inside. So we actually don't need the rubber inside. On this, with this of the 5 mm, you might just can make it 2 mm, something close, or you want it to be something extremely tight. Then another thing is we measure from here to here. Sometimes you want to use that. Some customers don't want enough gap. We don't want that much gap. Measure that's 5.5, which is okay. Go further, but it's okay. 5.5. So max 5. So if we're looking at from here to the face of the door, see something that's 5.5 as well. So that's what we're trying to do. 5. Most cases, some want this thing to actually lap properly, and some people also like to put padding inside the door or insulation, stuff like that. So I want to leave allowances depending on the need for the enclosure. What kind of ratings the enclosure comes with. So I'm going to end the half section and do the one from the top to show you what we do for the inch as a consideration. In some cases, so if you look at the side, the gap between the top and the side are different, and that's because we want to make room for the inch. Look at from here to here is 17.25. So that means that's the width of the hinge we put in there. And another thing we're considering is when you open this door, we don't want it to clash. Sometimes once you put the hinge, you also need to also make a close and opening to make room for the tolerance. So so in most cases it's best to put your hinge and test it out how it works. So if you look at it, that's 2.25. So I want to check the distance between the interface of the hinge and the and the face of the flange. I mean the face of the door and the face of the flange are still just close, so tight, very tight. Because you can increase it. If you increase it, you know that the hinge will not sit on this face again. You might need to extend this further, and want to be careful extending further because it might not be achievable, manufacturable anymore. So that's why I still want it to stay within certain minimum tolerance, or not do those things at all. You don't have your work come back for rework. So this is the hinge downwards that I've brought in here. And you measure from here to here. So it's fully flushed, and the passing from inside inside. So none of the fasteners is visible outside to this what the hinge is. So those are the things we make, the gambles we consider as in selecting the hinge. So if you look at this hinge is CL203 inch. If you Google CL203 inch, you see this type of hinge from Enclosure, and it's common in the market. So these are accessories that we find locally in Nigeria too as well.